So, welcome to the last session of today. It's been a very long day. We have a wonderful panel. You know them already, but so starting from the far away, we have Professor Anne-Sophie Rigaud from APHP, Marc Heide, professor at Lincoln University, Dr. Séverin Lemagnan from Pal Robotics, Vicky Charisi from University College London, Professor Raja Shatila at Sorbonne Université, and Cyril Lyotard, CEO of ERM Automatisme. So the title of the panel and the topic of discussion roughly is, are robots ready to be out there? And the first question that I wanted to ask is, let us start with potential uses of social robots. In which kind of environments and for which kind of applications would such robots have more impact? So I may turn to either Cyril or Séverin. That may be the better place to answer that question. And just one note, please be close to the microphone when you speak, otherwise they will not hear you.
Okay, so let me start. I'm happy to start. So yeah, as I said this morning, we have had some years of experience about the deployment of social robots in the field. So mainly the marketing analysis we did on the market in 2016 or 17 was that education and health were probably the two first fields where it would be easy or at least possible to deploy the robots without too many obstacles. And we discussed with Vicky during the pause, autistic education or children with special needs is clearly one vertical market where we see a lot of interest of the robots, because there is we can see the progress of the kids in each sessions. So there are some research all over the world about that. Probably in the next 1, 2, or 3 years there could be some kind of mass deployment of robots. So today the situation as we see it in France is that we haven't injected a lot of AI in our softwares, so it's more like guided interactions with between robots and kids using games and so on. But clearly in the near future it will be very useful to have AI embedded in that. In health, another pretty cool experience that we performed in Lyon, so close to Grenoble, in 1 hour west of Grenoble. We used the paper robot for welcoming children before medical surgery. And so the interest that was identified by the team was that would doing some kind of entertainment with the robot at this stage before the surgery would allow lowering the level of medication before the surgery. So that's today we have one paper running in that hospital. So and clearly I think in the medical field there is a lot to do also. C'est vrai.
I'm glad that at least someone knows how to sell robots, because we are terrible at doing that. The good answer is, I think no one really knows. The only market that has been widely successful in terms of general public use of robots is vacuum cleaners. You probably have a vacuum cleaner at home. It's not exactly social, even though I did run with students a long time ago, like a lot of studies about how anthropomorphic those robots actually were. But I think that's not the kind of robot we're talking about. Today, a company like PAL Robotics, which is not very big, we are 100 employees, but it's one of the few that has survived, I would say. We're celebrating 20 years of existence. I think maybe like 90% of our robots, we sell them to universities. And that's the only market that seems to be there and going. It's very stable essentially because universities keep on buying robots. But where the market like outside of research, and if we're not talking about like vacuum cleaners, I think we don't really have the answer because, and I'm going to connect back to what Raja was saying, I think the main question is we don't really know why we need robots. I was spending a month in January, like very recently, last month, in an hospital in Badalona, close to Barcelona where we live, trying to figure out with the nurses why they would want a robot, doing all the things, the perfect things like Vicky was describing, like let's involve the end users to come up with them with a use case. We came up with a lot of ideas, logistics, we will save them a lot of painful walking in the hospital to fetch the medicines and things like that. But after like a week, they say, well, actually, it's much faster for us to go by ourselves, and the robot is too slow, it got lost. We don't really need the robot for that. And they came up with like one use case. We need at night to make sure that people are still in their bed and they didn't fall from the bed, which is something really important to us, stressful for them. Is there a market there to sell like hundreds of thousands of robots whose only job will be to check if people are in their bed at night? You can probably just stick a camera there or like some simple sensor in the bed or something. So, I mean, Cyril seems to be very optimistic about the fact that we are going to sell robots to schools, for instance. Well, maybe. Usually schools, as soon as you tell them the price of a robot, they say, oh, let's buy a tablet instead. So I don't know. For a company like ours, when we are not selling robots to research centers, we try to rent them, like for events. We went to this big retailer for Christmas, and they wanted to have a robot in the entrance of the shop because it was so cool. The robot almost worked. It was impressive. We were not expecting that. But by that I mean they didn't bring it back to us after 2 weeks, but they did not keep it after the month. So it was not. But it was okay. It's not very satisfying, right? A robot that is just there for the woo effect. Is it really what we want to work on? Is it what we call social robots? It's a fancy machine to attract more customers inside. And actually it was really interesting because, okay, so I promise I'll stop speaking after that, but this anecdote is really fun because we were like, okay, so we need to have a way to, like people will come to the robot, and then we need to find some activities to do with the customers to, I don't know, like show them around what are the nice fancy clothes they could buy. So we came up with some ideas like that, and the company told us, no. We want the robot to get people in the shop, but then we certainly don't want people to spend more than 1 second with the robot, because if they do that, they are not buying stuff. So you need to program a robot that gets people in, but then is the worst possible interactor, because we don't want people to stay with the robot. We want the people to go in the shop. We are like, yeah, okay, I guess that makes sense if the point is just to get more people in the shop. So it was probably not a very good example of a social robot. It was an anti-social robot that would get people in and then get people to buy stuff instead of interacting with it. So I'm sorry not to answering. I didn't really answer your question, but I don't know why. It's not that I don't know why they are not yet there. I don't know where we even want them. We're still fighting to find a good use case for robots, but I'm sure you have ideas.
By the way, of course, you can step in at any time if you have something to say, right? I mean, they can, of course, continue sharing knowledge to you, but it will be also awesome if you can share knowledge back to us.
Challenge us.
Or give the solution.
Even better.
The solution is more work from you. Well, I think it's actually quite straightforward. Robots don't work. So basically everyone who has developed robot knows that they are not reliable enough. And therefore you cannot use them for critical applications. You can send a robot on Mars, and the robot on Mars shows a lot of reliability actually, because it worked for more than it was intended, but comparatively, Mars is a very simple environment when you compare it to human-robot interaction. Humans are a very complex environment. In addition, it's a critical application, which means you can do harm to people. So you don't want to take this responsibility. So basically, they are not reliable enough to be deployed in critical applications, and this is where we need you. They can only do simple tasks because they don't understand anything. So they have to be programmed. They or can learn, of course, but rather simple tasks. So I think this is why, for example, there is a difference between robots and AI. AI, the AI today, the AI what we speak about when we speak about generative AI, etc., doesn't deal with the real world and its complexity. So you can ask anything to ChatGPT, it will reply to anything with a lot of good, correct information and false information, and it's written, ChatGPT can make mistake. Please consider verifying or whatever. So it means we cannot trust it. A robot you need to trust. You need to have answers that are going to be transformed into actions in the real world. And we don't know, as a scientific community at large, how to do that. So this is why AI is successful in terms of selling products that do things which are not completely reliable, but it's okay. And robots are not successful because we need some reliability. So vacuum cleaner specifically, if the robot fails, it's not important. If a robot at care homes fails, wow, it's important. And we don't know how to do that. So we need more research. We need more understanding about how to develop these machines. And of course, this has been going on since years and years and years, and progress is slow because it's complex.
Can I add something? Yeah, I totally agree with all the people before me. But also, probably there is an aspect that of what we call AI literacy. So I totally agree with people that all of us have great expectations, but eventually I would also expect from people not to have such expectations from robots, right? So I'm not entirely sure how we are going to reach that because we, especially with children, we run experiments where we explicitly say that this is a machine, we remove the shell of the robot and it is like cables, etc. And still children perceive it as kind of their friend, right? So there is something there that probably has to do with human nature. But still, I think educating people on how to interact and what to expect by robots, this would be also a factor that would help for a greater acceptance in real life situations.
Right. I of course cheated, and I used ChatGPT, and it's glorious. Everything works. I can tell you, right? It's huge amounts of domains for social robots that you can use them in, and how it is written, or a response to my question, what applications are there for social robots? It all reads as if it is perfectly working. So far, I agree with Raja. I think that it will come back with an answer, and it is a nicely contextualized answer in some regards, but it doesn't tell you anything of the problems at all. Even when I followed up a little bit, what got the problems in there, there was a sort of, some discussions around some technical problems. What I found interesting is, at the moment, I think we agree, right? The main success stories of all the hundreds and thousands of peppers that were out there, marketing works, and that's completely reliant on the novelty effect, where robots are still something novel, at least in their shape and form, and are good enough to drag people into wherever they may be. That works, okay. I think that's probably soon going to end as a sort of novelty effect. Now, what I don't fully agree with is Raja's point that they just don't work. I think they work quite well, and we will see, and we haven't had the large language model moment in robotics yet, where all of a sudden people get excited about it and it's a massive breakthrough. But we see them quite working in many different domains already. and we see probably more and more social abilities being embedded into that, I would argue. And that paves the way to make them useful in certain tasks and make the interaction more fluent and more intuitive, and the interfaces and the interaction with humans probably more more easy. Also probably addressing some of the problems that I hinted on, like safety-wise, right? Regulatory aspects. When they have an awareness of what people are doing, so you do a lot of stuff also in tracking human bodies, etc. I think that is an ingredient of social robots, so they have an understanding of their social encounters, let's say, which feed into that sort of. So I think they will see some incremental progression in that sense, that where application domains where robots are useful already, and I would say, for instance, we've played around in agriculture, they are definitely there, and people are using them, and they have to face the problems that come from the human-robot interaction side of things. So we'll see that there is also from projects like Spring actually cross-fertilization in that direction that makes these robots in that sense more compliant with a human-populated environment, I would say. What I found an interesting domain that was also actually mentioned in here is telepresence, right? Because we've seen quite a few players entering that field, and I wonder whether we are more on a sort of road towards incremental autonomy, from a pure telepresence device to a telepresence device that provides embodiment in people's homes, for instance, independent living to some extent, which ends up being there permanently, doing some bits, but also serves as the contact point to a human in the back end. And that human in the back end may, be called by the robot. As I've said before, right, when something goes wrong, and something goes wrong could well be something goes wrong with in the living environment that the other person is in, so that they serve as the sort of permanent proxy to establish as a proxy the human-human communication. I see that as potentially an avenue towards that, right? So that we see that this technology gets introduced. Comes with its own challenges, but that may end up being then cheaper robots. They can't do everything yet. They are just a screen on a stick, but slowly we add more to that. And so I think we won't have this moment that we have the generally usable household assistant with 2 arms that does everything, right? It will probably be more towards initial proxies. Just a thought.
I just wanted to add a small point. I think it's very important to have more and more use cases, and in all kind of fields, because and I think it's very important that robots might be for everybody, because as far as health is concerned, it's rather limited to people with handicap, disabled people. And for example, older adults think a bit that having a robot is a bit stigmatizing, in fact, because you have a robot because you are disabled and you need help. We had a look at, we saw in another project, in fact, two nursing homes. In one nursing home, the older adults were regularly going to a restaurant where they had a robot. And that in another nursing home, they had no access to any robot. And when we gave them the robot, the nursing home where they were used to go to a restaurant where there was a robot, it was not stigmatizing. It meant, for them, for the older adults, it means that everybody has a robot, so they should have a robot. And the other nursing home, for them, it was stigmatizing because we were bringing a robot to the nursing home because they were disabled. It was stigmatizing. So it's very important, I think, that people will accept more and more robots if these robots can be for everybody in the museum, in the agriculture, for children in good health, for everybody. I think that's an important point to increase the acceptations of robots and then to use them more.
Can I So Raja, you made a really interesting point, saying like LLMs, if they fail, that's not the end of the world. Essentially, you can afford to put a little sign saying like be careful and check things, but we cannot redo that on robots. You're right. It's much safer to fail for an LLM than it is for a robot. But I think that's not the reason why. When ChatGPT was introduced, in November 2022, like a year and a half ago, right? And it's now a tool, whether or not we like it, that is used on a daily basis as a tool by millions of people. The news you're reading on your computers right now, they are probably being written by ChatGPT, or at least edited by ChatGPT. Why? Because it's tremendously useful. ChatGPT is just saving all of us a stupid amount of time. Look, Mark didn't prepare anything. Even during the panel, he was able to get an answer to the question. And I think that's
a wrong one.
A wrong one, yeah. But that's the thing. We are quite tolerant because we can indeed fix that. But so yes, we certainly have the problem of hallucinating an action for a robot is probably more dangerous than hallucinating a fact for ChatGPT. But I think the core issue is that ChatGPT is useful and our robots, with few exceptions, because even our Roombas, I'm not sure they are that useful at the end. At least we have one. We don't use it very much anymore. I don't think we have a very clear use case for robots. I think the nice one is the robot that can do everything, all the chores at home. And it seems to me that we are going in that direction as well. There is I don't remember which company was demonstrating again one of those humanoids folding your clothes and things like that. We've seen videos like that for a long time, but the latest one was I seen it a few days ago. Anyway, so people are still working on that, and that might be a use case where suddenly we will want to get robots in our homes. The telepresence one is an interesting one because I always tend to tell my students back in the days when I had students, playing chess. You remember that, it was in '97, right? That blue thing, deep blue thing won. But maybe you don't remember, but before that time, chess was the benchmark of AI. Like the day a computer will beat the humans at chess, AI is solved. Now, no one exactly that we were laughing about that. Of course, my mobile phone in my pocket can beat the best grandmaster in the world. And telepresence robots, I said robots, right? They are probably the day they become something that we can use on a daily basis. No one will consider them as robots anymore. They are just like devices that we have around us in our environment that are tremendously useful. But we are probably moving the cursor of what we call an autonomous robot, a social robot. And okay, I'm not going to try to make the case that Roomba was a social robot when it was introduced. It was not. But I think a little bit like AI, we're also working against competing against a moving target. Our expectations are moving. The introduction of LLMs in AI is completely changing our expectation of what an autonomous, intelligent system could do. So that does not help defining when we will have robots because,
No, maybe it would be interesting. So you said that the problem, or one of the problems, is that robots are not useful right now. So then my question would be, what are they missing to be useful? What kind of skills, what kind of capabilities should we try to push so that they actually become useful?
There was a saying a long time ago about AI. It was a long time ago. The saying is, when it works, it's not AI anymore.
Exactly. No, but that's very true. Yeah.
So when it works, it's not a robot anymore. For example, is an automated metro a robot? Everyone says no. But it's a very simple one, actually. It's a very simple robot. And to make it work, there has been a lot of engineering to automate it. Automate it means it works in an automated fashion, which is completely safe and verified, etc. So this is the extreme end. What we need is the capacity to develop robots in more complex environments and for more complex tasks. But when they will work in these environments and tasks, they will necessarily become more automated, which means less capable of multi-function, multi-task, etc. So it will be probably something which is developing progressively to address more and more capacities, more and more tasks, but starting small. And then maybe they will not be called robots anymore, but I mean those devices. But this is the way. I mean, more complex tasks, more complex situations, but progressively.
I just want to react to something. You are using the word automated and
Yes.
not autonomous.
Yes.
Is it on purpose? Can
Absolutely.
you clarify?
Let's leave away the philosophical point, because autonomous means you give your own objectives to yourselves, and only humans can do that, which means they decide for themselves what they do, etc. Robots work in a context that has been defined by the designer, by the humans, and their autonomous, what we call engineering, from engineering part, their autonomous capacity is in a limited context, in a limited set of tasks, and then they can decide by themselves to reach a goal, but it's in this place. If I decided beforehand that they will not get out of this place, they will not get out of this place, unless something goes wrong. And what does this mean? It means it's a very advanced automation when you have defined the environment in which the system works. So we have a continuity, if you wish, between automation and autonomy. Speaking about machines again. And if you want to speak really about an autonomous machine from the engineering point of view, etc., it means really much more complex environments. And we don't have this ability today. So progressively, we are pushing the frontiers for more advanced automation in more complex environment and more complex tasks. This is what I wanted to say. But when you define the environment exactly, it's more or less automated, because it's going to use its knowledge to be algorithmically more or less repeatable.
What the people expect is more interaction, in fact. At the moment, when we speak with people, with older adults in good health, or they're very interested in robots. They like robots. They enjoy to have them at home or in the nursing home or in the hospital. But clearly, when they speak to the robots, after some sentences, some one or two exchanges, there's a failure. This is the main limit, I would say, very simply. And another one is most of the time the robots have a limited content. For example, when it comes to games, entertainments. So the content is limited. So the people, older adults, we know older adults in good health. They are very curious. They want to always to see and learn new things. So the content of robots at the moment is too limited. So I would say these are the limits, the main limits for the people. Very practical, in fact, very practical.
Okay, so I'm gonna try to answer the question, what features, the first question you asked, basically. So just like Raja mentioned it much earlier, I think it's not a good idea to try to dissociate it from the wider sociological context. That is, you're always gonna have people that don't, a big part of the adoption of robots is people accepting robots And I think people are aware that right now the uses we propose for robots are not the ones they would like to see. For instance, if we're talking about, well, my field is, my PhD is in intralogistics, for instance, and people are very scared, some at least, of the possibility of being replaced by robots as far as manufacturing is concerned, for instance. So I think if you only consider economic incentives, people are not going to be very kind to the idea of having more robots in their life, and there's always going to be some kind of fear, uncertainty, and doubt towards the robots. So, like, I think the wider context, the question of why we're introducing robots, the question of, as Raja said, why do you need a robot in the first place is very important in that answer.
So my question is, I'm of the belief of a generalized AI in terms like the whole goal is to have an AI that can behave like a human. And so one of the difficulties I have with my research is trying to come up with a complex task and situation that could be used to prove that it is a generalized AI, I would say device. So I was just wondering if you guys have any ideas of what type of task. I know there are several different tasks, like people say education, like if you can learn math, but we've seen that with GPT chat and others that they can do that. So what would you say would be a good example as a new benchmark for that?
It's not an application. It's a capacity, a capability, understanding the environment. What's this?
But my question to you is, how can we quantify that? How can we quantify understanding? You know, that's the question. And so people come up with different ways for behavior analysis. So my question, I have a loud voice, so my question is, what kind of litmus test can we do? And I think that would be helpful because like all my research that I do, everybody says, oh, we've done it. And I look and say, wait a minute, that's not good enough. So if we could have a litmus test that truly does define what we say about cognition, evolution, all of that, I think we could make a progress as to the type of, we can definitely know if what we created is worth it. And we can then say, oh, this is trustworthy. We can do all of that. So my questions to everybody, especially the panel.
The textbook answer to your question is the Turing test for robots. And there is something called like that. I don't remember the details.
They've proven that the Turing test
is crap, yes.
Exactly.
So I was going to say, as soon as you define a test like that, it's not useful anymore because people optimize for it, because you start actually thinking of the problem in terms of models, and as soon as you're able to build a model of that, you will be able to find a solution. I think the point that Raja is or maybe, I don't know, the way I understand what Raja is saying, and that's also my opinion, is that the problem is dealing with what we are not able to model, because by definition, we don't have a model for that. And there is tons of examples of that. You were talking about education. I think the best 2 hours of my life as an academic, when so proud of myself, I went to a preschool with a lovely robot, like designed for those kids. It was a nice, the robot was called Ranger. It was a little box on the wheels made of wood, lovely, with big googly eyes. I can show you pictures. And the idea was the robot will help kids to tidy up the kindergarten, like super nice. Within 15 seconds, they jumped into it and started to organize a race in the kindergarten. It was fun. The robot did not like it, so that's why instead of lasting 2 weeks, it did last 2 hours. We went back to the lab with broken robots after 2 hours. But that's such a good example of understanding chaos. It was completely unexpected. Humans around it made complete sense of it. It was obvious that the kids would do that because it was just fun. But build a robot that is able to understand what's going on there.
My opinion is we will continuously go through this circle if we cannot define. Like, we're all human beings. At some point, somebody out here someone should be able to determine a litmus test that we can use, either a framework somewhere, because we know that there are a lot of psychologists here, and they could probably say, bring a cup of pigat. I know it's a French name, I can't say French, but there are these tests. So my question is, why can't we come up with a test that I can use?
Just a quick answer about Turing test. I don't think it's proven that Turing test is outdated or doesn't work. It works perfectly. Turing test, if you take really what Turing said, it's the conversation, but it's not about this conversation. It's about you cannot distinguish the machine from the human. And I don't have a recipe for that, of course.
Just before giving the microphone to her, I just put my mathematician hat, and in what you're saying, you're assuming that such a test exists.
I do believe it does exist.
Okay, I'm not that sure.
Thank you. I would just like to add to that, like just as an example, like for example, ChatGPT, the kind of essays it writes. So a lot of times, like my sister, she tried it. She sent me some results, and I could swear it was written by either some Indians or some Chinese students, because when I read it, because like this is how we learn, because English is not the first language. This is how we learn to write. We learn from templates. And a lot of times, like I could swear it was written by one of my friends, the style, the writing style is so similar. So, I mean, yeah, just by reading such things, like it's not like, okay, we are deviating a bit from robots, but at least like the technology behind it, it's very hard to say whether it's someone who is not a native English speaker or whether it's ChatGPT who has written it. And even in my school where I'm teaching, so we're having some issues in kind of figuring out whether someone has written it themselves or not. So we're just gonna ignore this topic and just focus on the quality of what they've done, rather than figuring out whether the student did it themselves or not, because we're using such AI as well for helping us prepare the course plan. But yeah, I mean, I agree with this. It's just in this kind of bias, like even whatever techniques which we are trying to use to detect whether it's been done by a human or not, like we have to be aware of these kinds of cultural elements as well, and how someone learns a language in some other countries. So I think that's very important. And yeah, so the Turing test, it could be really interesting. It's like you just don't know whether it's a human or not.
I just connected the dots. I think we can connect everything to the Chinese room experiment. The problem here is that I'm connecting to the baseball experiment. The fact is, if the machine doesn't have any knowledge about baseball, you cannot detect as a machine or human. The problem is that even if they have the knowledge, they don't have any sense to that knowledge. So here is the philosophy question about what intelligent, what does it mean to be intelligent? So that's why they were some of them they were indicating a bottle and say what is this?
Yes.
Because they can detect that is a cap, because they were trained to imagine of a cap, but they don't know what a cap is. It's an interesting point, but the problem is about the cognitive, about the conscience. That's really interesting. I found it very interesting.
That discussion can last a long time, because we are talking about pretty fundamental questions around AI now. So I love this kind of question. So maybe we should do that tonight with a beer or something. But maybe you want to bring it back to robotics.
That would be great. I think Mark is going to do that.
Well, I'm trying. So I've got I've got a reading recommendation. I don't know if you all know this. A Robot in Every Home by Bill Gates from 2007. Have you read that? No. So I recommend looking that up. It's an interesting one because promised at that time that we will see a similar evolution as we've seen with the PC market that Windows obviously was quite keen on. We will see that, but the challenges that he put out there are actually, we could almost have a checklist and look at some of these aspects. One is about modularity, right? And that we can have versatility. I think one, and that for me, from robotics perspective, comes, we have two pathways at the moment. One is the one towards automation that Raja's outlined a little bit, right? We have specialized tools that do specific tasks really well and reliable. Take autonomous cars, not that they really happened yet, but you know, it's the sort of same story. It just is, job is to get from A to B on its own. And that's probably one of those, and I think we heard intralogistics. There's lots of really, really good robotics work in intralogistics that works and avoids having to deal with that with a human, right? So that's one path of like focusing, really optimizing hardware and software for that particular one task. The other way, the other option is to create a sort of overall versatility, which at the moment, and this is the problem, comes with an incredible amount of costs associated with it, with robots, right? The moment we have the home robot that solves everything and can do your dishes, load the dishwasher, fold your clothes, all this stuff requires a really, really huge degree of investment. It comes at a heavy price tag. I think it may even be possible to build something like that, but there won't be a market for that because the price tag is so extraordinarily high to do something like that. So, and that's different, I think, when we look at, what we can do, and in this article he even makes these references about interfaces and modularity. So one problem I see also is the robotics industry, PAL does great stuff, but they are not compatible with other components quite easily. So what we need to do eventually is having like an environment like an app store, right? Okay, I've got my basic platform, costs me whatever, 5,000. It's a Roomba that cleans some, but there is the extension kit that I can now buy, and I download it and I get it. It's unfortunately it's not as simple as that, right? You cannot just say I download an app and it works. It's not just a platform because we have got this embodiment challenge with it. But if we have some sort of aspects of modularity in that, then it becomes potentially interesting. But he's going to
no, but just what and Sophie was saying, we are lacking content on the robot.
Yeah.
So my immediate thought was we need an app store.
Yes.
Funnily enough, or maybe some of you know that Aldebaran, who are manufacturing paper and now, they did start an app store for now and paper.
Yeah.
They ended up with a couple of applications. But the problem is the dev kit is quite expensive. You need to buy a robot if you want to develop things on there. And then the market does not exist.
Exactly, it's super small.
So there is not a lot of incentive to build an app for an app store that does not have any.
But that's the sort of infrastructures, that's at least what also is posted in this sort of environment here, in this article here, is that, we need something like an app store effectively for robots. And that's because of it is actually... if it were that easy, say like I'm just going to equip this robot now with an ability to wash my dishes and it comes at a reasonable price tag, then that's fine. But at the moment, I think that's not there. And just to answer the question about the test, but I would in the end say I think the Turing test has a massive problem in that sense that it tests whether it can be confused with a human. Why would we build a robot that is like a human, right? We build machines to be better than us. That's why we build cars, so we can go faster. That's why we have a hammer, because it hurts to hammer a nail in with your hand. So we always use them to go beyond what we can do. That's why I don't believe in the sort of generic C3PO robot or something like that just does what we can already do. I think we've got 8 billion people in the world. So there's no point of making mechanical ones, but we will have ones that get better. And so from my point of view, in that sense, the ultimate test is, are they useful and are people willing to put money? It's an ultimate test.
I actually have a question for you. The thing is, I worked for like 6 months in a startup, a robotic startup, and 2 months after I was out, it crashed and burned because it's super expensive to build robots, basically. It's super expensive to sell robots, and you need specific uses that people would want to have. My question is, currently you have this huge improvement in LLMs, in conversational speakers, things like that. Are we going towards very fancy speaker time, or are we actually going to need the embodiment and the robots in the future? Is there a future for that?
If you want to fill the dishwasher, you probably need to have arms.
Sure, but currently, if you look at the social robots that are being built, most of them cannot open my dishwasher. They don't have the arm capabilities, and the price for arms, the price for parts.
Just before taking your comment on that, a very brief one. You might have heard about Astro, the robot built by Amazon. It still exists officially. You can still buy it. But I know very well the people. I know I have good friends in that team. Who knows about Astro? Raise your arms. Okay, a few of you. Knowing the marketing powerhouse that Amazon is, I'm sure you've all heard about Echo, like the smart speaker. Astro? Not so much, right? And we are a bunch of roboticists. Why? Because no one wants to buy a robot that is basically useless. It was a very nice little social robot. You could do one thing, carry around a can of Coke in your home. People didn't buy it, surprisingly enough.
May I say something specific to your dishwashing? The essence of automation is that you change the environment so that it can be automated. So you interact with social media change you so that you can interact with social media easily. Now, you don't need an arm to open the dishwasher. You just put an automated door to the dishwasher so that when your robot wants the door open, it sends a message and the door opens. By the way, your dishwasher is a robot.
Yeah, the thing is, then why do I need even a robot talking to me or a robot opening a dishwasher if the dishwasher can unload itself and do whatever I want by itself? I don't need something talking to me for that, or a social robot for that matter.
While it's doing the dishes, your dishwasher can talk to you. Like I talk with my wife when I do the dishes.
So 2 problems solved in one.
About what? Yeah. So then this goes back to my question, which was, do we go for something that is going to be, let's say, I don't know if you've heard about replica or equivalence. So yeah, this kind of companionship, or a robot that would be companionship robot, or are we actually building something that would be useful in other cases?
The cynical answer is depends where the money is. If you want to pay for that, build you a replica robot. Sure.
I think when you speak about robots, I mean real robots, the point is action in the real world. Otherwise, we're speaking about something else. So if you need a robot, it means you need action in the real world. And there are a lot of needs, but we don't know how to do this, as I said.
Yeah, I think the issue is that everyone expects us to have like the one robot that does all our chores, but why do we need it? Why don't we just have a washing machine that throws out the clothes into a basket and the basket can roll through the room, and then we have a automated washing stand that just like sits down and the basket throws all the stuff on and then like stands up and wraps it around or something. I mean, we don't need one robot that can do it all.
You should hire her.
Yes, because you'll become a competitor, so no?
Well, for that you need all these things to talk to one another, right? That's some part of modularity. Modularity doesn't necessarily mean everything is screwed onto the same body that can move about. Modularity also means that you may have this sort of additional, I don't know, a dedicated whatever company's washing machine that is compliant with your home automation.
It already exists. It already exists.
What exists?
Like a dishwasher that integrates with your domestic IoT network, where you can remotely control them, know how much detergent you've put.
Yeah, but it's still mainly in the sort of virtual world, I would say, right? So it's all data driven.
Yeah.
This is the problem, I think, because I want to just say your question was about, do we still need robots to interact with the physical world? And I would say yes, but there's actually fewer and fewer domains where this is the case. And that's probably important for us to recognize. One is maybe for entertainment. That's probably not going to be the big one, because I see this. I mean, there's lots of robots, social robots, also being used now for entertainment and interacting with kids. I think the trend goes, if I look at my own children, they are much more embedded in the virtual world. there's a few applications where I would argue we can't go without interacting with the physical world. That's our body, that's care, effectively. So that's clearly also requiring interactions with us because we are physical entities. I would, from my own perspective, I would say food is another big one, right? We need to grow and eat stuff. So it comes down to very basic human functions in some regard, where we can see that we will not see a society moving completely away from the physicalities. And the other one is probably energy. So, when you think about how we generate energy, as sort of some domains that I see physicality still being around. I was provocative. I hope I got a trigger response.
Yeah,
I think I succeeded.
You will get it. I mean, I don't want to live in a world like that.
That's a different matter.
That's the short. No, but it's an important matter because right now, I mean, with SoRAIM, we are the two who are building the robots, so we can decide to stop building robots because we don't want a world like that. It's fine. But my point is, we have, and the reason why we have this winter school, is also to make sure that we're not going to agree on the big vision for robotics, but at least that we raise those questions together, so that the generation that is tomorrow going to be the one controlling all the pipeline of how we build machines can have all the ethical values that Raja summarized so nicely in his talk in mind, so that we build the world that we desire and not the one that is easy to build, or the one that our kids that spend way too much time on TikTok and Netflix ask us to do right now.
Mm-hmm.
So we should stop building robots.
No. I didn't say we should stop building robots, did I?
But no, you didn't. But I think we should not discard the physicality. I think there's way more physicality in our world, and our desire of having a physical interaction with the world is much bigger than just food, energy, and healthcare. I think it's also something we deeply want and define ourselves through our physical contact and interaction with the world. If robots can support that one way or the other, amazing. If they cannot, then we can do without them.
Indeed, and I agree with SoRAIM. Sorry,
no, that's
especially
great.
for children.
That's the whole point.
I mean, we do have evidence now in terms of mental well-being for children and the use of, virtual, screens and online world, etc. So there is evidence now about the negative impact on children's well-being.
Absolutely.
So probably here there is an opportunity for the embodiment of robots, right? So we want for children again to be in the physical world because of several reasons of their development, especially in the young age. So probably here there is an opportunity, right? So I mean, if you people can build the right robot, this is not my job.
No, but just I think the question that I have then, would we want them then to interact with an embodied AI or a robot instead of other humans? Because at the moment we would argue that they interact with other humans through the proxy of social media.
Not necessarily.
And
I mean,
I don't think there's a need to oppose them. It's not one or the other.
No, I'm just saying, because I think at the moment most of the negative impact comes from that there's so much screen time, that social media encourages interaction remotely with others.
Not
Probably
only this.
To some extent.
Exactly. So it's not only the
I didn't.
Go ahead.
I didn't hear. Sorry.
Go ahead.
So I think the issue that you were trying to say is that it's the algorithms behind that feed negativity, and that's what the kids see, and then that gets propagated, and that's the issue. And so if we have embodied robots that bypass as a firewall, we may not.
Exactly.
I think that's
exactly.
Mark does not agree.
No, I don't know. I've made up my mind, actually, to be very honest. I think it's whether you're right. It's the algorithms that are the most harmful content, and this constant feeding of new content. I think we're going to go in a massive tangent here. I'm just not sure that robots are the answer to that. Is my main thing, because I'm not sure that in that sense embodiment solves that. I mean, if these robots, if these sort of types of algorithms are deployed on an embodied platform, I'm not sure it makes it necessarily better.
I don't have a strong opinion yet, right? So intuitively, I would say that at least we can use embodiment in order to bring children again in the physical world, and trying to make use of the positive, the possibilities that we have with these kind of machines. For example, personalized learning or this kind of thing. But so we make use of these opportunities again of AI, etc. But at the same time, we bring children in the physical world, which might lead also to better social interaction among children, so they can get rid of the robots in the end, right? So I don't know. What I'm trying to say is that personally, I see kind of opportunity here in terms from bringing children again into the physical world, especially because we have this evidence, which is especially, the last after from COVID, and so the last 4 years.
I don't doubt that. Just to be clear, right? I don't doubt that they can be a very powerful, also therapeutic tool in that sense, right? To reconnect with physicality and everything. And I think the point that SoRAIM made is really, really well put. I pictured a dystopia, absolutely, right? By saying, we are reduced to just our main bodily functions, and that's of course a dystopian view, right? So the interesting bit is, of course, what else makes us human? It is, for instance, leisure, going out, enjoying nature, and those sort of things. Whether these are interesting opportunities to utilize robots, it's an interesting new perspective for me, at least. I haven't really thought about that, but I'm just saying, because in response to where is the actual physical interaction needed, that's where I said that's main motivation from a sort of purely market-driven perspective. What is the things that are going to stay as absolute physical needs? That's the ones that I came from, right?
Maybe a slightly to try to come back to recenter a little bit the discussion. This question of the impact of the robot or the why we need a physical intelligent device. It's something we explored a little bit with Vicky in this study we did took a paper robot in a school for autistic children for a couple of weeks, and the idea was, so the robot, like a lot of studies on social robots for autistic children is mostly about I'm going to make it worse than it is, but let's fix the children by teaching them about recognizing emotions, things like that. And it was we took a completely different approach. We said, okay, we're going to put a robot there. It's a bit of a blank canvas, decide what you want to do with that. It was not only about looking at how the children would use or not use the robot, but it was also about looking at how the robot would change the dynamics of the school. So we were trying to take this ecosystem-based approach, looking at the broader impact on the children, on the staff, but even on the school, as the school is not a thing, but as an organism where people mix, mingle, move around. And I guess even if it was completely disembodied, if we had a similar technology completely disembodied, it would also have an impact on the school as a whole. But clearly being physically there, present, something you can bump into, something that will look at you when you pass through, has a very different impact on the dynamics at play. And that's certainly what makes robotics interesting to me. It's a much more complex, richer interaction that we're talking about. There's this kind of situational awareness. That's what's going on. That's something like Echo, like a smart speaker, the best one cannot really deal with, right? So I think that's maybe quite unique to robots.
Cool. I'm going to do another provocative thing, because coming back to the sort of test question, I remember from this was a kind of other research seminar, we had similar discussions, and somebody suggested, because it also came from autism research, I said I went through an autism test with my robot in mind and tried to fill it on the behalf of the robot. And it's shocking, of course, if you think about some of these tests questions are very much around awareness, social interaction, social reading, social situations, being very much focused on one specific things. And so they came back and said what all our robots are is they are the most autistic beings in the world, which I found. So it's going to be very provocative to state that, but it's an interesting test.
It's not provocative in the sense of, I don't know if any of you have been reading literature in research on autism. It's extremely inspiring. because basically over the last, it's kind of old literature compared to what we're doing. But people like Simon Baron-Cohen, for instance, is one of the big names in this community. Like and other colleagues, like 10, 15, 20 years ago, they came up with a range of models of how cognition develops or partially develops, and ways of testing that. So, okay, that's indeed something that connects maybe to your comment. That is amazing and can be applied almost word to word to robotics. I wrote this paper in 2015 called like Next Steps for something for robotics. No, not for that. No. Something very clever. The title is always very clever. Where basically I took the literature in research on autism and I said, okay, all those tests, all those experiments that have been done to assess autism, let's apply them directly to robots, because that's an amazing way of measuring what they cannot do. Yeah. So that might be part of your test.
Yeah.
I'm not saying the paper was good. It was a long time ago.
By the way, robots are used in research on autism to interact with autistic children because they are easier to read for the child, which goes in your direction, because robot is actually not as complex as a human who is not autistic. So
they are repeatable also.
Yes,
so you can,
exactly.
The child can ask 10 times, 15 times, repeat the same thing, and the robot will not show anything on his face. So at the end, they feel confident in having an interaction with the robot. So that's in a nutshell what comes from the studies. Yeah.
Let's not start the discussion about robotics and autism, because that's a long one.
So when it gets serious, we have to change.
Okay, so if you're interested in the topic, I highly recommend you to read what the work done by Brian Scasaletti, a professor from Yale, who is one of the really leading researcher in robotics and autism. Because he did, I remember one of his talk that was mind-blowing. They took, the Sphero robot, so it's a very small round robot, and just that moves around autonomously. It's really fun, actually. It's a ball that rolls autonomously and can change colors. Very simple robot. And they said, okay, let's figure out why children that are pretty high on the autistic spectrum really seems to be able to interact with those robots way better than they do with humans. And they took every single possible hypothesis, like they are more repeatable, they have easier models of emotions, they are the shape is easier. I think they tested for, if I remember right, for 7 hypotheses. And so they did a massive study, cross-testing, for children, for the robots, for the modality. Their conclusion, unfortunately, is that there is not a single parameter that was sufficient to explain the behavior. So the conclusion of years of work on that question is they don't know why those children like to interact. And because it was clear that those children that would refuse, for instance, to interact with humans, except maybe their parents, and even that, were kind of starting to cuddle the robots, to interact with the robots. So it was obvious that it was effective. But yes, you know better than me, actually.
No, I don't know better than you. But also what we have observed with autistic children is first, exactly what you said, and then we don't have the novelty effect eliminating so fast, right? So we had, in a previous project that I worked with autistic children, we had long-term interaction with them, and it seemed there that we didn't have this. Although, again, we had a limited amount of tasks, etc.
So it's a long wow effect, basically, a longer wow effect. Maybe
it's fascinating.
It's fascinating indeed. It's fascinating.
And it's the same, in fact, for people with cognitive impairment with social robots. In fact, there's no novelty effect because of memory impairment. So you can give the robot every day, and there is a memory that they have interacted of a robot, but it's always a novelty. And since they do not feel that they are judged by the robot, the interaction with the robot is very easy, and some people with very severe disorder, they can talk again with a robot whereas they cannot talk anymore with the human beings. And sometimes they even say to the robot things that they wouldn't say to the humans. So it might be a bit frustrating for the people around them, but it shows that it can be very useful and helpful for these people.
Yeah, thank you so much. This has been a very interesting discussion. I had a lot of questions, so I'll just ask one. And yeah, I wanted to add to what she was saying. So first of all, that yeah, so instead of like having one robot that does everything, wouldn't it be more interesting to just work on some like modules which can be added to, let's say, like a washing machine? Because we, like a lot of makers, those who participated in maker fairs and those who are working with Arduinos and Raspberry Pi, sure, we're trying to do these things at home, but then it's like not as reliable because we're not that, we're not that good with the technology, we're not really doing this professionally. But wouldn't it be better to bring down the cost and just try to market these individual components which are customizable but reliable, rather than make some expensive, like let's say some people, they market like some kind of pre-programmed, let's say, thing like a smart washing machine, a smart whatever, a smart, it's like that thing. I mean, it's very hard to sell to people because first of all the price is high and you're not getting much. But these individual things, they will bring down the cost, and I mean, people are more likely to at least try them because they're cheaper. And maybe we can try to have a common platform for people to share their experiences with such things, like not exactly an app store, but that could come later. But at least so, because so that if we have a common platform for these things, because like for example, Arduino, Raspberry Pi, that's why they're working, because there's a common platform for people to work on and try these things, and we can have user studies. So it's like more of an open source thing, but for like, these kind of like extensions to let's say appliances and all.
So you hire them.
To be honest, it exists to a large extent, maybe more than you suspect, at many different levels. So software-wise, ROS is probably the best example of that. Hardware-wise, it's probably not as nice and as easy to use as easy to use. Easy to use as ROS. But there's a very simple example, for instance. Today, grapers, if you want to grasp something, the price of a graper goes from, I don't know, the cheapest are probably around 100, 200 euros. The most expensive one, super fancy hands, are probably like 10,000 euros, dollars, pounds, whatever, or more if you want. But they all connect together with the same connector. So it means that if you have an arm, you can just. There is standards. I'm not saying that you cannot get like a fancy one that has a different standard, but there is standards, and you can even like, so you have your arm, you can almost plug and play your gripper. You can also add like a force sensor if you want in the middle. So now suddenly you have like a gripper plus a force sensor. The thing is, all those components first, they are still pretty expensive, and you still need the know-how to assemble in a robot. But it was kind of interesting to talk with where is it? At lunchtime we had a chat about the fact that in the US a lot of universities are just buying a mobile base, buying an arm, putting a screen, and up they have their mobile manipulator instead of buying like fully integrated ones. And if these things are possible, it's because it's actually easier than we think, or easier than it could be anyway, both in terms of hardware and software to assemble things like that. It could be better. You did mention open hardware as an attempt to have more standards in that direction. If you want to have like a really funny 5 minutes check the work from EPFL on modular robotics, there are cubes that size that can move by themselves and build furniture and things like that. That's amazing. But that doesn't really replace. You still need to put a gripper if you want to.
I've seen that. I've been following such work actually, but like for example, like there's a kid who wants to do something still I feel like a lot of these things, they're kind of limited in terms of like application for people who don't have a technical background. So that's one of the key challenges. You know, like for example, Amazon is selling a robot, like it's sold like some kind of household appliance, right? So I think like the marketing, or at least the way we design the product, it should be such it's customizable, but also like, you know, for example, for making websites these days, there's drag and drop for designing, you know, your website. Like now people don't need to code to make their website. So like similar thing, like some AI literacy, but also whatever like we are packaging, you know, whatever we are selling, it needs to come, like the product needs to be such that, you know, it's not just a DIY thing anymore. It's like anyone can work with it and they start feeling comfortable with it. So, you know, people can just design solutions on their own. I was just thinking of it like from a product based point of view and also from a marketing point of view, because, and also it's really impressive how you guys have such a huge team and so many teams are communicating with each other for the Spring project. It must, I mean, I assume it must be quite challenging to communicate and, you know, get things done sometimes. Like you must have such a streamlined process, right? It's really impressive that you guys, like so many of you are working together on ARI, and really amazing.
It does cost a lot of beers.
Not too many. I think, Mark, you wanted to say something?
Yeah, some of that has been said now, but because I wanted to make the point about the maker community. I find it quite interesting that if you think about 3D printers, they are probably also the robots that kind of start assembling themselves, because there's a lot of people who mod them, continuously add stuff to that, and because the community has grown, it becomes easier and easier and easier these days, right? So they are 3D printers that print themselves. I mean, in software, it's always that when you make a compiler, the main milestone is when the compiler compiles itself, right? And in this is sort of 3D printers are the sort of robots that build themselves in a way. And maybe that's actually some important bits that we think about, that this becomes more of a standard tool, that people can expand their own sort of robotics platforms, that sort of more, and we have more sort of social capability skills that we add to that. I think that was an interesting observation about the sort of maker spaces that exists, and we probably have to see that coming forward. I forgot the other part that I wanted to make. I'll come back to you.
So you have a question here, and then I want to ask a last question, maybe to change a little bit the sense for the final 10 minutes.
So I have maybe a good idea or addition to the use cases of robots in general and embodied robots. We already talked about it regarding to the kindergarten and school, and I think it's important, even if solely for the educational purposes the robots were there, it is worth it, because there might be a child who, when he or she sees how the robot works and everything, they can come up with more solutions. So solely for the educational purpose of the kids, it is worth, because they can come up with much more answers than we know now. So I would say there will always be some usage of it, even if it was this, it's just worth it to build the robots.
That kind of connects to Vicky's comment on AI technology robot literacy.
Yes.
In Spain, when I moved in Spain 2 years and a half ago, I was amazed to see that primary school, every year from the first year to high school and after, they have robotics as one of the main topic. So they do robotics every week.
It should be.
So they learn to use, and it's based on Lego Mindstorms or this kind of kits, so that they build things. So it's possible. I agree.
All right, so we have 10 minutes, and I was curious. So we've discussed about generative AI. We saw how an LLM was working on ARI on Monday afternoon, and we saw that it's not really an LLM for ARI, in the sense that the LLM was trained somewhere, and then you put the software there and you turn, now you are a robot, and you are in a hospital, and blah, 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 blah. So we have seen foundation models appearing for all other tasks, many different tasks. And now my question is there going to be a foundation model for social robotics? Is this the answer to part of our headache? one part of the answer, not the answer at all. I would like to hear what you have to say about that.
We tried last year to submit a European project that was exactly about that. It did not get funded, so we need to try again. So
But
my
to answer that question,
my
or
answer
to
is
actually build?
not to build it. My answer is yes. I think so. I think none of the models we have today, even though there is a lot of work being done in making them more and more multimodal, there is efforts, as you probably know from Google in particular, to you've heard about the RT2. It was really interesting to hear from you that actually Google decided not to continue pursue that venue. So we will see that there's definitely like a lot of companies and universities working in building models like that for robots that are very multimodal. If you look at all those really fancy, cool, nice results, none of them involve humans because
So
that's hard.
They build models for robots or for social robots?
For robots. So that's exactly what I think that the next step, I mean, all the foundation seems to be there to progress to adding humans. It's going to be I think a pretty big step because of all what we know and what we've been discussing about the complexity of the not only the humans but the human world, full of chaos and meaning and things like that we. But the promise is, and I mean, LLMs are making. So you were talking about the Chinese room argument earlier on. I think it's a moot point today. It's not really relevant anymore in the time of LLMs, the Chinese room argument, because you can ask an LLM what a bottle of water is, and it will tell you something about that.
Yes, but it's not a bottle.
No, but it will be able to provide something that by all definition would be the meaning of what a bottle is, even though it doesn't have the intrinsic understanding of what it is. Anyway, I said we should not get into this long discussion about the fundamentals of AI. But my point is the promise that those models are showing on language. I don't see why. I see no fundamental reason for those not to apply and to be extended to the social world. That's my view on it.
Yes, SoRA, which is okay. So it's multimodal and providing more and more realistic videos and animations, etc. And this is going to continue, but it will hit the same wall that real robots hit because of the complexity of the interaction with humans. Even large language model, which have a lot of data about human-robot interaction, maybe, etc., still will lack the understanding of what it is to interact with a human. So I don't see a way to solve this issue because of a basic limitation which is in these systems. So my answer is still no. And you might, of course, again, as I said, if you limit the task, if you limit the complexity of the interaction, resolve the problem for this specific scenario. But it's not solving the problems of human-robot interaction for the same reasons.
Right, I'm thinking of a somewhere in between. What I find interesting is with these foundation models, what we have settled for, well, we are impressed by the generality, let's say, right? And this may then also happen to robotics and even to social robotics, that we have got some generally working solutions, but we seem to be somewhat sacrificing, let's call it optimality. What I mean by that, and this goes back also to a discussion that I had with Manuela Veloso at some whatever robotics conference it was, CMU professor, and she was quite furious in a panel discussion like that because she's seen so many papers where people used deep learning to replicate robotic stuff for which we knew already an optimal solution, which had a closed form solution problem. I'm giving an example of planning a path from here to over there given a map. right? We know Dijkstra solves this search problem optimally. But there were papers now being done which kind of solved the same thing effectively with some machine learned policy reinforcement learning. And now this is probably a similar worry I have if we do this more and more, that we gonna settle on something. Yeah, well they'll do something. It will somehow do the job, probably, and be quite generalizable, but it will probably do a relatively poor thing, as the LLMs do today in terms of text generalization. And that's why I wanted to quickly also make this point, because I forgot who it was who said, like, it's, yes, I think it was Raja saying, you know, it's fine an LLM may make a mistake. If we make a mistake in robotics, that's much more severe. The problem is we don't have a clear test whether they make a mistake as well, right? They generate some text, something comes out, and we're not entirely sure yet whether they make a mistake, because the mistake only happens when decisions are based on that sort of information. And that's, robotics is all about decision making. But that comes back to a more general discussion I see also when we come to robotics here. The problem is when these systems take decisions. And this is already a problem not only just with robots deciding to grab the cup like this or like this. These systems, AI systems now that we have got, are often used as recommender systems, and they often work on a sort of also mission planning level. Let's take a military domain, where indeed we had in Germany, there was a court case because some whatever they were, major, colonel, whatever, had taken a wrong decision to actually order a strike on a tanker in Afghanistan. And so, you know, a lot of civilians were killed because it was the wrong decision. They thought there were some terrorists or whatever, and it was petrol, but it was a water tank. It was fresh water delivery. And they killed a lot of innocent people. There were court cases around this. The reason, the main defense for that was that all the AI systems that they used, that analyzed that data, suggested that. And he was basically let off, right? Because all the evidence that was gathered that supported his decision making were there. Now, that leads to the point that people will trust these systems more and more, because that takes the risk away from them. Even if, you know, we have a human point where we make a good decision and say, like, well, you know, my guts tell me we shouldn't do this, it's too risky, we shouldn't do this, they will probably be in trouble afterwards, because they haven't got the evidence that is generated by AI to back up their decision. And that's why I'm very cautious when military folks in particular tell me, oh yeah, we will always have a human in the loop before a trigger is pulled. Well, what's the point if they have a human in the loop if they're not empowered to take actually human decisions to some extent? And that's some of the worry about these foundation models. Then we think about robotics.
It's always dangerous to refer to high stake. That's why I like the AI Act that takes a risk-based approach. Yes, you probably don't want to rely on ChatGPT for the lethal, highest risk AI decisions. I give you that. Hopefully we're not talking about social robots that are going to be the one killing people on the field soon. I think it's not, well, maybe at some point, but in no way implying that we should just let those machines decide by themselves. I think the question was, does it make sense to have like a foundational model trained for social robotics? And yeah, I don't know what the point I wanted to say. I said yes. I don't think you're actually saying like we should not.
No. I'm not saying you shouldn't, but I think that's when we go in that direction, then we must really be aware of what we are asking. And I mean, my main point was optimality, right? Because we don't have a clear idea of what the correct model, what the correct solution is.
So that's a brilliant point. Like there is nothing worse than re-implementing something worse than what we already knew how to do. But in the case of social interaction, or even LLMs, you could argue that we don't have an optimal model. So we are competing against nothing. Anything is better than nothing in that sense.
Well, I was mainly making the point in this case we probably need a test, because it's not quite clear what this is, and whether that is a test then that identifies, well, it has cognitive ability equivalent to a human. It's probably not the right one. But I think it's because I don't know why your project was rejected, but it would be interesting to know what the sort of what you put as KPIs. your proposal.
So maybe you can discuss this with a beer, right? So we are reaching the end of this panel, and what I would like from you guys in this very last time, in maybe 1 minute or like 2 sentences, is what do you think is going to be maybe the future step or the next challenge that is going to be addressed, or the next challenge that will appear, or the next issue that we will find? What's going to be, one next thing that we will find in social robotics research and technology development? That's a very hard question, and I would randomly start with Séverin because he was already raising his hand.
Well, foundation models in robotics.
I did not raise my hand. No, the one thing that I'm excited about, we haven't really talked about it today, but we started to work with students of mine, and I think it's an idea that is now kind of growing in the community about taking robots start with some knowledge of a task. But
we said 1 minute, huh?
Yeah, so sorry.
Yeah.
It's basically using lifelong machine learning for robots, where the robots learn from the users, and so you don't really define what the robot does at the beginning, or you might define it at some level, but quite vague, and you let every single user to teach the robots by showing, by doing with them, by sometimes remote controlling them for a little while until the robot knows how to do things. And that I like because, first, I don't have to answer the question, why do we need robots? That's the user who will decide. But also in terms of from an ethical point of view, it's becomes your tool. It's not something that I impose on you. It's you design the tool as, if you don't want it, you don't use it. If you want it, you can shape it to be your robot, the one that is actually answering your needs.
Okay,
and
great.
There's some really interesting first results in that direction. That's it. Very good.
Mark, I think you wanted to...
Going to say genuine curiosity, which kind of follows up in these sort of footsteps. Because I mean, at the moment, it's all like one direction. We teach, we do whatever, and shape it. But I think we need a creative process with social robots, which means they must have some level of genuine curiosity that they exhibit to actually come up with, sort of ideas and learn proactively, not reactively.
Thank you. Anne-Sophie?
I think people really like robots and the embodiment of robots, and I think although if we cannot achieve an interaction with a robot like an interaction with people, I think we still can make progress because at the moment there are still, I think, progress to do. And I think that people will be happy with robots that can interact more than nowadays and that have more content than nowadays. I think there's still a large field to fill up, I think. And I think also that people have people have different, might like different type of robots. So I think it's also a good thing to continue to develop different type of robots, such as maybe platforms or social robots like animals, or more like human-like robots. So I think even if we cannot achieve real interaction, there's still a lot, I think, that can still be done to fill the needs and the preference of people and what they expect from robots.
Right, wonderful, thank you.
Yeah, I think that probably I would rely more on this generation to answer that question. So I'm really looking forward for even more creative people than the people that we are sitting here. I mean, for me at least. So to find a way that robots could contribute to a better society for the future.
Thank you.
Well, I think very clearly that we can accomplish more with social robots if we followed an ethically aligned design approach, because this will better define their objectives, their functions, their operations, and and also the interest of the companies who are developing them, not just the users.
Thanks.
Yeah, on my side, just want to make a kind of small business situation, because it's what I do. Basically, today, I believe that the innovation will be driven, or the mass deployment of robotics will be driven by use cases. So, and probably we have to look at Asia. They have the rhythm of development and the deployment of robots is faster than in Europe and USA. I take just an example. Today we are able to have a room service, which is a robot. So in hotels, it's already in Asia. It will arrive in Europe quickly. So going from the desk to the room, calling the people inside the room, discussing with it in some extent. So it's a very limited social interaction, but maybe one day they will add incrementally other features on that robot, and it's a service. It brings value to the activity of the hotel, I guess. And my wonder is, once there is a real business behind that, like thousands of hotels worldwide, that the company will put hundreds or thousands of engineers working together in the development, then maybe there will be a big gap, a big step. Because today, if we look at the picture of robotic development, we have plenty of researchers working on their side. You have a few companies, but it's I would say startup companies, like a few dozens or few hundreds of engineers. But we don't have the big guys. Even if the Amazon projects and Google, I don't think they put a lot of engineers in that project. But once we get the teams of thousands of engineers with what we have as a basis in AI and hardware, probably it will be a game changer.
All right, thank you, Cyril. So I would like you to join me on thanking the panelists and all the contributions that we get from you.